And welcome back to Darvin's Chem Corner.
So we're going to do 4 different examples of everything we learn right now. 2 of them are, not 2, 1 of them is very important for your quiz, and we'll get there. This is number 3. So right now we're going to do BF3. And the first thing you do when you approach this problem, you should do these 4 parts first. So right now, Cassidy, you're going to be my assistant.
Okay.
Where's the... Tell me the
Using the periodic table.
Huh?
I just...
Okay, so to recap, remember we talk about the valence electron. To determine the valence electron, it's the sum of all the valence electron within a formula. So what's the valence electron for B, Cassidy?
3.
3. What's the valence electron for F?
7.
And is it just 7?
It's 7 times 3 because there's 3.
Very good.
There's 3 fluorines.
So this is going to be 3. This is going to be 3. Let me rewrite that. It's going to be 3. Is it 3?
It's 3.
Times 3?
7. No, 3 times 7.
Okay, there you go. 7 times 3. And that's going to be 3 plus 21, which is?
24.
24 valence electron. Maybe make sure, because giving you shitty shit answers is just wrong. That's correct. Now we gotta do the stab. And remember the device to memorize stab. What is it, Cassidy?
HB ball.
HB ball. Is there an H? No. Is there a B? And by B is BE. Is there a BE? No. But is there a B for ball?
Yes.
Yes. So let me write it down. H B ball.
HB ball. You can say HB ball.
HB ball. This is 2. This is 4. These are 6. And since I wrote this down, I know that B is 6. So B is going to be 6 plus F. F is not one of them, so any element that's not that is
8.
8 what?
8 times 3.
8 times 3 for F3. And this is simply 6 plus 24 equals 30 electrons. Let me make sure that's right. Oh yeah, that's right. So I'm going to reiterate what we said. So stab is the electron configuration, and we learned from our HB ball that B has a configuration of 6. So you're going to have 6, and stab is the sum, just like the valence electron of this formula. And since F is not one of these, it's only going to be 8, because every other element besides these 4 are going to be 8. So it's going to be 8 times 3, because there's 3 fluorine, plus 6, which is 30 electrons. Perfect. So now we gotta do bond. This I don't remember the bond equation. So
I think it's stab minus val.
Perfect. Like I said, but I didn't say anything. Like Cassidy said, bond is stab minus val. I cannot stress enough memorize this. So stab, which is 30 minus 24, is going to be 6. 6 bonding pairs. BP. I am hot.
Take off your jacket.
Oh, too much fat. And now, what's the form for lone pair, Cassidy?
Val minus bond.
Yes, that's correct. Val minus bond. Like I said, cannot stress enough, memorize this. So val is going to be 24. Bond is 6. 24 minus 6 is...
18.
18 lone pairs. So now you found all of your calculation. And technically, you can use this to draw your structure, but it never helps me. So if it helps you,
I would suggest only using the valence electrons.
Yes. So I'm going to draw it out for you, and I'm just going to draw it straight from my handy-dandy cheat sheet. BRF3, right?
Mm-hmm.
So you're going to have...
No, not BRF3, just BF3.
well, shit. Oh yeah, okay, yeah, that's right. So B, there's a double.
Oh, then can't you talk about the special thing here?
Actually, you can't. You can't talk about it because they don't have another one up here, so you can't switch it around. But we'll get to that.
Wait, yes, you can.
We're not going to do it for this one.
Okay.
What we're talking about now is resonance, and problem 3 is a resonant problem, and I will stress this enough. I can't stress it enough. There will be a resonant problem on your quiz for a lab. I missed it, and it was 17 points. I missed 17 points. So this can technically be, so let me talk about it. A resonance is basically multiple ways of writing a structure. So right here, we can technically write this as like this.
Oh, yeah, too much.
So basically, there's multiple ways of writing it, and you have to write all of them next to each other. We'll get to an example like that, but like right now, this can technically be a resonant problem, but I'm not so sure, because I didn't use a resonant problem here. So right now, this is the structure of your formula, and we can technically, hold up, give me a moment. 24, and you can, like I said, you can actually use a lot of these to check your work. 24 valence electron. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 22, 23, 24. 24 valence electron. You're good. Or right now, lone pairs. How many lone pairs? 1, 2, 3, 4, 5, 6. Never mind. Screw that. Just use this to check your work, like Cassidy said.
Just use the valence electrons.
So now we gotta figure out what shape is this. So remember the step I told you to name a shape. First, electron geometry. How many electron pairs are there? 1, 2. Believe this or not, this is considered 1 right here. So it will be 3. Yeah. So right now, if you have double bonds in one area, it is considered 1 electron pairs. So remember that. This is 1 electron pairs, not 2, okay? I can't stress it enough. Do your practice. This is 1 pair. So 1 pair, 2 pair, 3 pair. And what is a 3 pair called? It's called a trigonal planar.
Trigonal planar.
Like the booty 2-timing bastard. And how many electron pairs does it have? None. When you're naming a model, you have to look at it in respect to the middle element. The middle element has 3 electron pairs to it, but no lone pairs. So it has no lone pairs. It's just a trigonal planar. I'm lazy to write again. So the shape is called trigonal planar, basically. The dipole or polarity. We're going to talk about polarity and dipole because they go together. Because remember we said that when it's polar, there's a dipole. When it's non-polar, there's not dipole. So the question is this structure polar or non-polar? How do we figure that out? It's not there. The electron negativity. So which of these, B and F, has more electron negativity? The way you can do that is look at the periodic table. So Cassidy, which one's more electronegative?
Well, here's B, and here's F, and everything in this corner is more electronegative. So I'm gonna go with F, Darvin.
Yes. F is more electronegative because it's closer to the top right side of the periodic table. So the way I show more electronegativity is the arrows. Since F is more electronegative, they're going to absorb more electron from B. So all the electrons are going to go towards F. It's going to go towards F. It's going to go towards F. And remember the rules for polarity and non-polarity. The shape is non-polar if the electrons are going opposite direction. It's going opposite direction, so it's going to be non-polar,
You were.
and non-dipole. I'm too lazy to write the whole thing down. Non-polar, non-dipole. Got it? And degree, it should be, is it 120 degree over
It
there?
is 120.
Okay. 120 degrees. You have to memorize that. See? Simple? Done. This is exhausting.
Do you want me to do it?
Yeah, Cassie, you can do this one.
Okay.
So
Here,
we're gonna
just
do
hold
a
the phone.
trade off.
I'm not even gonna explain it. I'm just gonna do it.
Yeah. You guys understand the explanation of this. She's gonna do this and I will explain it for you guys.
Ah, I got caught on this. Okay. So S has 6 plus. Is that a 2?
Mm-hmm.
Okay. F has 7 times 2 plus 6 plus 14. It's 20. It's not any of those, so 8 plus 16, 24.
Wait, I made a typo. Sorry. That's a 4.
It's a 4?
It's a 4. It's a 4.
That's 28 then. 28 plus 6 is 34. This is now 8 times
You're correct.
4, which is 8 times 4 is
40.
It's not 40, that's times 5. Oh, so then minus 4. 36? Is it 36?
8 times 4 is 32.
8 times
Plus
5
8.
is 40.
8 times 4 is 32.
Are you sure?
8 times 5 is 40. So 8 times 4 must
Oh yeah,
be
so you
32.
subtract 8, not subtract 4.
Yes, there you go. Got that on camera.
So it's 8 plus 32, which is 40.
Yes.
Okay.
Thank God
so
y'all
then-
calculators. So to
then
reiterate,
bond-
we're gonna look at the valence electron is the sum. Keep going, Cassidy. So
Bond is-
at the valence electron for S is 6. The valence electron for F is 7 times 4. 7 times 4 is 20 plus 6 is 34. Now the stab configuration, there's none of them as F4 matches with HB ball right there. So they're all of them are gonna be 8. So it's gonna be 8 plus 8 times 4 because there's 4 fluorine. So it's gonna be 40. The bond and lone is all from the equation, so memorize that, for God's sake, memorize that. You are correct, and you are correct.
Okay.
And I'm going to draw the thing for you to save you some time.
I want to draw it.
You want to draw it?
Yeah, I want to
Go ahead.
Okay. So
You guys may skip the video. Very good. I never mentioned the octet rule, but you guys get that, do you?
wait, there should be 34. I have 1, 2, 3, 8 times 8. No, 8 times 4 is 32.
So
Did I
how
do my
many
math wrong?
valence electron do you have right now?
There should be 34. Did I do my math wrong?
How much do you have right here?
8 here.
No, but like in total.
Oh, in total,
Yeah.
32.
So if
Oh, there's just like. A
yes,
lone
ma'am.
pair
That's
here?
perfect.
Okay. That was weird.
So now it has 34. So that's how you guys know how lone pairs are created.
Okay.
That's perfect.
I don't
That's
like
correct.
That, but it looks stupid. So the shape, it's 4.
The shape.
So it's there's 5
Why is it 5?
because there's a lone pair, but it's still an electron pair.
Yeah.
This is an electron pair. This is an electron pair. This is an electron pair. This is an
Yeah.
electron pair.
So all pairs, electron pairs. This is an electron pair too. So 1, 2, 3, 4, 5.
So it's
Electron
a-
pair don't have to connect.
It's a trigonal bipyramidal.
Very good.
But it has.
Don't look there. Don't look
One-
there. Look at. Try to use the.
No, I was
thing.
just turning towards you. So
Yeah.
it has one lone pair. So it's also seesaw.
And how can you memorize seesaw?
Still.
Still. Very good. You want to write that out. Write still to
Oh.
show them. So STILL.
So this is seesaw.
Very good.
This is T shape. Oh, why did I put the A right there? T shape. I can't spell, but this is T shape. And this is linear.
And you just go in order. 1 is S, 2 is T, 3 is L. Very good.
Okay, and because F is more polar than S, they're all going different directions.
Mm-hmm.
But there's a lone pair here.
Yes.
So it's a space window.
A space window.
Means it's polar.
Very good.
So there's a dipole, so yes for dipole, and it's polar.
Yes. Very good. What's the angle?
90 or 120.
Yeah, either or.
I looked at the board for that HE.
I know.
I couldn't remember.
Oh shoot! Very good, Cassidy. Very good. I hope you all got that shape in dipole, cause that was amazing. I feel so proud because my teaching got somewhere. Okay, so thank you, my lovely assistants. So now we're gonna talk about number 3.
Resonance.
So right now, number 3.
I gotta get back to my spot. Okay.
So number 3 is a very. Why did I thought I was gonna do something?
Just leave it.
Okay, so like I said, let's just do the math first. How many valence electron does N have?
Do you have the periodic table?
No,
It's right
you
there.
should have. You're my assistant.
I'm the assistant. 5.
5? Okay, 5. How many are there?
3 of them.
3.
Wait, but there's a negative. Does that have to do with anything?
Give me a moment. That's what I was thinking to myself.
I burped twice during
yeah.
this video.
So right now, what's 5 times 3?
15.
15. And now we gotta think back to the last unit. What does it mean when there's a negative?
It means there's an extra electron.
An extra electron. Very good. So the final answer is
16.
16 valence electron. Don't forget that, people. Remember, when it's negative, add electron. When it's positive, minus electron.
Subtract.
That's some very bad reverse psychology there. So yeah, so I'm going to reiterate. There's 5 valence electron for here, and there's 3 nitrogen. 5 times 3 is 15, plus 1 because it's extra electron, okay? You guys understand that, I hope. So the stab basically goes through the same process. So we're going to look at H, B.
It's none of them.
B all. So it's going to be?
Still none of them. So 8
times 3. Which is 24.
Do we still have to add an extra one?
No, because stable configuration, it's not valence electron.
Okay, so it only has to do with valence.
So you got to worry about that.
Got
so it stays 24. What's the bond?
24 minus 16. Stab minus val.
Val minus bond.
Nuh-uh.
Stab! Okay, fine.
Val, it's stab minus val.
So
24
16.
minus 16.
It's 8. Lone pairs?
Val minus bond.
Val minus bond. So 16 minus 8 is 8. 8 bonds pairs and 8 lone pairs. Sorry, I'm going too quick, but so now we gotta draw it. And I'll tell you, if you draw this, there's many ways to draw it. Not many, just 3, but there's many ways to draw it. So I'm gonna draw it the first kind.
Do we have to put into those brackets?
You have to. You have because there's a charge.
Yeah, I'm just clarifying.
Like that. And what you can realize that this double bond can be distributed many ways. So basically, what I'm saying is, this structure can be drawn two other different ways, and we call this resonance, meaning that different structure have the similar process. So that didn't make sense, but oh well. So I'm gonna draw it the other way. Right there. So when I did this last semester, I just drew this. it did not hit me that this double bond can be a single bond and a triple bond, and a triple bond and a single bond. So you have to be very careful. This is what we call a resonance, where you can draw the structure many different times. And for the quiz and exam, you have to draw all of it, or else no points. And the yeah, and so this is good. I drew all three types, and all of them follow the 16 valence electron. That's how you check your work, okay? My suggestion is try to look for resonant last, but don't forget it, okay? This was 17 fucking points, people. That's a D right there. So yeah, that's how you draw it. And now we gotta find out the shape. How many electron pairs are there? 1,
2.
2. 1, 2. 1, 2. Remember, this is one pair, not 3. 1, 2, 1, 2, 1, 2. And what that's called?
Linear.
How many lone pairs? None.
Okay.
Remember.
Oh, on the central atom.
You look at the central.
On the central one, there's none.
Yeah, and yeah, perfect. On the central. So is it linear? Linear. The question is it polar or non-polar?
I don't know.
So you should have been paying attention. I'm kidding. So remember the second rule of non-polarity.
Oh, if it's linear, it's automatically non-polar.
To reiterate, you're correct. When your shape is a linear or a planar, so trigonal planar or, yeah, this is trigonal planar, it's automatically non-polar, meaning no dipole. And the reason why is because all electrons are stuck. There's nowhere else to go. And what degree is it?
180.
Very good. So my recommendation is do more research on resonance. I can't give you a good way to memorize the resonance. It could be formal charges, and we don't have time to go to formal charges, but just like do more research on this resonant problem. This is a very good problem. So there's other resonant problem. Usually resonant problems are going to be linear, and that makes sense, right? Because you can do a lot with it. So you ever get like a linear problem, it could be a resonance. So
basically, a lot of the double bond ones can be written
Yeah.
as just stuff with more than one bond can be written as a resonance.
yeah, so there's more than one bond. Just keep that in mind, okay? Don't forget this. When there's a charge, you have to do in the bracket, you have to have the negative. Don't forget to add this negative into the valence electron, okay? This is elementary, people. No, it's not, because I didn't know that. This one, it's a challenge problem, and I will show you why, okay? So one, because there's three different elements, and believe it or not, the central element is P. Don't ask me why, I don't know. Usually the central element is going to be the one in the middle, but not this case. So, so right now, we're going to talk about the valence electrons, and I'm just going to give you the answer because you all understand how this works by now. The valence electron is going to be 32. The stab is going to be 40. The bond is going to be 8. And the lone is going to be 24. I'm going to draw it now. And this drawing might look weird. Okay, what do you notice different about this this model? That's the word, model. What do you notice something different? This, you know how others we have 2 or 1 elements? This time we're comparing 3. So right now let's look at electronegativity. So wait, let's just look at a shape first. What shape is this?
Tetrahedral.
Why? 1, 2, 3, 4. Any lone pairs?
No.
Tetra, tetra. I'm not going to write hedral because that's just extra. Very good. The shape is 109 degrees, 0.5. And the question is now, is it linear? Not linear. Is it polar or non-polar? So, how do we determine that? Let's look at our periodic table. Which one is more? Which one is less? Which one is more polar? Cl or P?
Cl.
Cl.
Doing which one's more electronegative?
You're right. Which one is more electronegative? Cl or P? From the periodic table, it's Cl. Now, which one's more electronegative? P or O?
O.
So we have more than one outer element. Just compare it one by one. Now the question is this polar or non-polar? What do you think, Cassidy?
Well, they're all going in opposite directions, so I would say that it's non-polar.
Very, very good. It just, plot twist, it's polar. I'm gonna tell you why. This is a special case. Cl is gonna have a certain length of electronegativity. O is going to have a different length of electronegativity. They're all going to be more electronegative than P, but they're going to be in different amounts of, like they're going to be, the length of electronegativity or the amount is going to be different. And if you look at my notes that I wrote earlier, the second rule is when they have different length of polarities.
How do you know the lengths of polarity?
Here's the thing, Cl and O are different elements, meaning that if they're both more electronegative than P, since they're different elements, they're going to be different amount of, they're going to have a different length amount of electronegativity.
Okay.
It's just like a concept thing.
Yeah.
They're different element, they're more electronegative, but they're not the same element, meaning that their strength of electronegativity is different. So when this strength is different, it's going to be polar.
So would it also be dipole?
Yes. This is the only case where when it's going to opposite direction, where it will be polar. So, yeah, guys, good luck on the exam, on the quiz. And this today concludes, Cassidy?
Darvin's Chem Corner. Do 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 do.